Alright, you are welcome again. Today, we want to talk about exact equation under differential equation. A differential equation that is said to be exact. How can we solve it? Okay, now let's take a look at this question. Show that this equation is exact and solve it. Now we have x dy dx plus 3x plus y is equal to 0. Yes, look at this question very well. We are asked to show that it is exact, and then if it is exact, we are to go further and solve it based on the question. All right, good. Now let's go. We have x dy dx plus 3x plus y equal to 0. Right? Good. The first thing we're going to do, let's write this in a linear form. Let's write it in a linear form. That means we multiply through by dx. We multiply through by dx. So multiply through by dx, we're going to have x dy plus 3x plus y in bracket dx equal to 0. Now, this side that is having dx, we're going to call it a letter. And then the side that is having dy, we're going to call it a letter. Okay? So the side that is having dx, we call it m. And the side that is having dy, we call it n. Okay? So here we're going to say that m is equal to 3x plus y and n is equal to x. Okay, good. Now, in this place as we have m is equal to 3x plus y, we are going to differentiate this m partially with respect to y. Okay, and then when we do so, that means every other variable will hold it constant. Okay, so the partial derivative of m with respect to y, 3x is going to give us 0, and then when we differentiate y, is going to give us 1. Now we go to n. We are going to differentiate this n partially with respect to x. So when we differentiate partially with respect to x, is going to give us 1. So here we discover that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, which is equal to 1. With this statement, we say that this equation is exact. When we have the part we call m and the part that we call n, the partial derivative of m with respect to y and the partial derivative of n with respect to x, if these two partial derivatives are equal, we say that the function or the equation that this m and n are coming from is said to be exact equation. Okay, so here we say hence the equation is exact. Now here we want to form a function. Let's say that this function is u of x comma y, and then this function u of x comma y, let it be a function such that the partial derivative of this function with respect to x is equal to m, and the partial derivative of this function u with respect to y is equal to n. So that means we're going to have the partial derivative of u with respect to x is equal to m, and the partial derivative of u with respect to y is equal to n. Okay, good. But from the beginning, we say that m is equal to 3x plus y and n is equal to x. And then in this place, we have m and n again. So we are going to replace the value of m. We're going to replace m with its value and then n with its value also. Okay, so that means the partial derivative of u with respect to x equal to m. In place of m now, we replace it with 3x plus y. Let's call this equation 1. And then the partial derivative of u with respect to y, which is equal to n. So in place of n, let's replace it with x. Okay, so that means we have the partial derivative of u with respect to y is equal to x. Let's call this equation 2. Now, in this place, we have two equations, equation 1 and equation 2. We can decide to pick any of them. We are looking for the function u of x comma y. So we can pick any of these two functions and then find our function u of x comma y. Okay, so if you pick the first one, you are going to arrive at the answer, and then pick the second equation, you are going to arrive at the same answer. Now in this video, we are going to take two of them and solve, and let's see whether we're going to take the same thing. Now from here, let's take the second equation first. Now the second equation says the partial derivative of u with respect to y equal to x. Okay, this function u is differentiated partially with respect to y, and we are looking for the function u of x comma y. That means we are going to integrate this function. Since we are looking for u, we integrate it with respect to y. Hello, so we integrate this equation 2 with respect to y, that is with respect to dy. All right, good. That means we're going to have the integral of the partial derivative of u with respect to y dy equal to the integral of x dy. Okay, good. Now from this place, when we integrate this partial derivative of u with respect to y, we integrate it with respect to dy, what is it going to give us? It's going to give us u, and then equal to, in the right hand side, when we integrate x with respect to y, it's going to give us x y plus, we're supposed to have c, right, constant, but in this case we're going to use the letter t of x. Hello, we're going to use the letter t of x. All right, good. Now we have the function u equal to xy plus t of x, and what we are looking for is the function u of x comma y. But in this place we have t of x, but we don't know the value of t of x. We want to find this t of x. Okay, good. We are going to differentiate this function now, u, with respect to x. Okay, let's differentiate this u with respect to x. That means we're going to say the partial derivative of u with respect to x. Why do we differentiate partially? Because we have x and y in this function u. So that means the derivative we are going to take is partial. Okay, so we're going to say the partial derivative of u with respect to x equal to, we'll differentiate xy with respect to x, is going to give us y. And when we differentiate t of x, it's going to give us t prime of x. Okay, good. So the partial derivative of this function u with respect to x is equal to y plus t prime of x. So this t prime of x is trying to tell us that it is differentiated. Okay, good. Now let's go this equation 4. This is equation 4, right? Good. Now let's go again. When we started, we say we are looking for the function u, right? Such that the partial derivative of this function u with respect to x is called the letter m, right? Good. And then after that, we have equation 1 and equation 2, right? Good. So what did equation 1 say? Equation 1 says that the partial derivative of u with respect to x is equal to 3x plus y. Is that true? Yes. And then equation 4 that we have now says that the partial derivative of u with respect to x is equal to y plus t prime of x. Now let's compare these two equations. In these two equations, we have the partial derivative of u with respect to x in both of them, and then we have y in both of them, and then t prime of x is equal to 3x. Hello. Comparing both of them, we see that t prime of x is equal to 3x. All right, good. And then we are looking for the value of t so that we replace it in our function u. Okay, but here we have t prime of x is equal to 3x. So for us to find the true value of t of x, not t prime of x, t prime of x is differentiated. That means we are going to integrate it so that we'll find the true value of t. Okay, good. So we are going to integrate both sides with respect to x. So when we integrate t prime of x with respect to x, it's going to give us t of x. And when we integrate 3x with respect to x, it's going to give us 3x squared all over 2 plus c. Okay, so we call this equation 5. Now, as we call this equation 5, let's go back to equation 3, where we have our function u is equal to xy plus t of x. Now we have found the value of t of x. Here we say that t of x is equal to 3x squared all over 2 plus c. So let's replace it. When we replace it, we are going to say that we have u is equal to xy plus 3 all over 2 x squared plus c. Hello. We see that u is equal to xy plus 3 all over 2 x squared plus c. Yes, this is the solution of the exact equation. We followed the second equation, right? Now let's go again and take the first equation and solve it. Let's see whether we're going to get the same value of u. All right, good. Now we have the first equation to be the partial derivative of u with respect to x equal to 3x plus y. And then the second equation says the partial derivative of u with respect to y equal to x. Is that true? And then the one we just solved now, we took the second equation. Now let's take the first one. The first one says the partial derivative of u with respect to x. That means we are going to integrate this function with respect to dx. We integrate this with respect to dx. All right, good. So that means we are going to say the integral of partial derivative of u with respect to x dx equal to the integral of 3x plus y dx. Okay, so when we integrate the left hand side, it's going to give us u, and when we integrate the right hand side, it's going to give us 3x squared all over 2 plus, we're supposed to have c, right, constant, but in this case we're not going to use c. We're going to say t of y. We're going to say what? T of y. Let's call this equation 3. All right, good. Now we are looking for the function u of x comma y, but in this case we have found u to be 3x squared all over 2 plus t of y, but we don't know the value of t of y. So if we succeed in finding the value of t of y, we'll put it here and then our problem is solved. So because we are looking for the function u of x comma y. Okay, so now we have found u, right, but it's not complete. So in this place that we have u, we are going to differentiate this function u partially with respect to y. Here we have t of y, and then we are looking for t of y, right? Good. So we differentiate this function u with respect to y. Now let's go. So when we differentiate, we're going to have the partial derivative of u with respect to x equal to, partial derivative of u with respect to y. All right, that means we're going to hold x as a constant. And then in this place, we have 3x squared all over 2. So as a constant, when we differentiate it, it's going to give us 0. And then when we differentiate t of y, it's going to give us t prime of y. All right? Good. Now, let's go. Let's call this equation 4. Now, from the beginning where we have equation 1 and equation 2, we said that equation 1 says the partial derivative of u with respect to x is equal to 3x plus y. And then the second equation says the partial derivative of u with respect to y is equal to x, right? Good. Now let's pick this equation 2 and equation 4. This equation 4 that we are having now, because they have the partial derivative of u with respect to y and then the partial derivative of u with respect to y. Okay, so comparing these two equations, what do you see? We see that we have the partial derivative of u with respect to y equal to x, and then the partial derivative of u with respect to y equal to t prime of y. That is to say that t prime of y is equal to x. Hello, that is to say that t prime of y is equal to x. But we are looking for t of y, not t prime of y. What are we going to do? And then t prime of y is talking about differentiated. Okay, that means for us to remove the differentiation, we integrate it. Okay, so we integrate with respect to dy. Okay, with respect to y, right? Good. So when we integrate both sides now with respect to y, the left hand side is going to give us t of y equal to, then when we integrate x with respect to y, it's going to give us xy plus c. Hello. So here we have t of y is equal to xy plus c. Let's call this equation 5. Now, we saw u is equal to 3x squared all over 2 plus t of y. And now we have found the value of t of y. Let's go and replace it. Now substituting equation 5 into equation 3. So we are going to see that u is equal to xy plus 3x squared all over 2 plus c. Hello, we have u is equal to xy plus 3 all over 2 x squared plus c, which is the same thing that we have the first time that we took equation 2 and solved. Okay, so here now, either you use the first equation or you use the second equation, but what we are looking for is the function u of x comma y. So, and whichever one you take, applying the right steps, you are going to arrive at the same answer. Okay, yes, thank you very much for watching. Let's take more example so that you will master it very well. Okay, let's go. Stay blessed.